Hi students, in these notes we will continue talking about angles, but we'll specifically talk about special angle pairs. These are two angles that together have a special relationship that we will identify and then convert into an equation that represents their relationship. The first definition we'll talk about is perpendicular lines, which you might be familiar with. These are lines that when they intersect, they form a right or a 90-degree angle. So when you see or hear that we have perpendicular lines, I want you to think 90 degrees. A picture of perpendicular lines might look like this, but until we are told that they're perpendicular, or that we see that little box in one of the angles, the four angles that it forms, we can never assume that we've got right angles. So let's look at example 1. Line NP and line QR are perpendicular lines, so we know that we've got some right angles. We've just been told. They intersect at O. Find the value of X. As long as you know you've got perpendicular lines, you technically know that all four of these angles are right, but you only need the box in one of the angles. So this angle that we know, 5x minus 5, angle NOR, we know it's a right angle, so we know that that expression also equals 90 degrees. And there's our equation. 5x minus 5 equals 90 degrees. So remember, your goal is to try to set up these equations. So let's go ahead and solve. We're going to add 5 to both sides. So 5x equals 95. And then we'll divide both sides by 5. So x equals 19. Easy peasy. So not all intersecting lines form right angles, but they do form four angles, such as in this picture. 1, 2, 3, 4. Now we're going to use this picture to talk about three of our angle pairs: adjacent angles, vertical angles, and linear pairs. The first are adjacent angles, and these are basically angles that are right next to each other. They share a vertex and they share a side, but they have no common interior points, which just means they're not overlapping each other. So a lot of the angles that we talked about when we were learning about the angle addition postulate were actually adjacent angles. This picture might look familiar. So this angle, kind of on the top, is adjacent to this angle down at the bottom. They both have a common vertex and they share that one side. So in our picture up above in the diagram, we have a few examples of that. We're just going to put one example. We might say that this angle up here is adjacent to this angle over on the side. They both share point Z, and they share this one side, ray ZX. So this angle and this angle are adjacent. So let's go ahead and write that down. As an example, angle, we could call it VZX, and angle XZW. Now we have vertical angles, and you may have learned about this at the end of Algebra 1, maybe not. But these are very similar to adjacent angles, but they don't share a common side. They are non-adjacent, but they do share a common vertex. And they're also formed by intersecting lines. So an example of vertical angles, if I've got two intersecting lines, would basically be two angles that are kind of across from each other. So this angle and this angle. This angle here and this angle here. Think of like a butterfly, maybe. They share that vertex in the middle, but they have no sides in common. So in the picture above, to represent an example, we might say this angle VCX is vertical to this angle YZW. Okay, notice they have different pairs of sides, but they meet up at Z. Okay, so let's write that down. Angle VZX and angle YZW. Another thing to know about vertical angles is that they are congruent, which means if I have expressions for both of those angles, I can put an equal sign between them because their measures are equal. Adjacent angles aren't always like that. Another type of special angle pair are a linear pair. Linear means line. So these are a special type of adjacent angles. They share a vertex, they share a side, but together they form 180 degrees. They actually form a line. They're what are called supplementary angles, which we'll talk more about in a minute. So anytime I have kind of like a line that's formed by one and two angles, we say that they're a linear pair. So in our picture above, a linear pair might be, let's see, angle YZV, this guy, and angle VZX, this guy, because together they form this line YZX. So that could be our example. Angle YZV and angle VZX. So linear pairs are also adjacent angles. So just to recap, vertical angles are always congruent. Okay? So if I have angles that are across from each other, they are equal to each other. So to set up an equation, you would say this angle and this angle are equal. The sum of the measures of angles in a linear pair is 180. So that means this angle plus this angle equals 180. So we've got two types of equations that we'll see a lot of. So let's try some examples. These two lines intersect at B. We are not told that they are perpendicular lines, so we don't know what kind of angles they intersect at. Find the value of x and the measure of angle EBC. So we're going to find the measure of this angle. So we've got some expressions for angle ABE, 2x plus 20, and angle DBC, 3x plus 15. These are vertical angles. They're across from each other. They share that vertex B. So remember, vertical angles mean they are congruent, which means they're equal. So the way we can set up our equation is 2x plus 20 equals 3x plus 15. And then we'll solve. So I might want to subtract 2x from both sides to get my x's on the right. So 20 equals 3x minus 2x is just x plus 15. And then I'll subtract 15 from both sides. So x equals 5. All right, so there's my x. Now I've got to find the measure of angle EBC. Well, I don't have an expression for angle EBC, but I see that it is a linear pair. Let me change my color real quick. It is a linear pair with one of my two vertical angles. So for example, this vertical angle, the 2x plus 20, if I add angle EBC to it, I'm going to get that straight line, right? They're going to add up to 180. So if I could plug in this 5 for x into 2x plus 20, let's try that first. So 2 times 5 plus 20 equals 10 plus 20, which is 30 degrees. If I know that this angle right here is 30 degrees, then I can figure out angle EBC by subtracting 30 from 180. So 180 minus the 30 equals 150 degrees for the measure of angle EBC. And that is my answer. This example is just like example 2 with different expressions. So if you understood example 2 and want to give this a try, go ahead, and then you can unpause it and see how you did. So again, these lines intersect at I. We don't know that they're perpendicular. We just know that we have an expression for angle GIJ and for angle KIH. These two angles are vertical angles. And remember, vertical angles, they are congruent, which means I can set their expressions equal to one another. So we'll start off by saying 16x minus 20 equals 13x plus 7, and then we'll solve. I'm going to subtract 13x from both sides. That'll leave me 3x minus 20 equals 7. And then I'll get my constants to the other side by adding 20 to both sides. So 3x equals 27. And then I'll divide both sides by 3. So x equals 27 divided by 3, or 9. So there's my value of x. We need to find the measure of angle JIH. That's this angle here. Well, just like last time, this angle, the 16x minus 20, and this angle JIH that I'm trying to find, they are a linear pair. They are supplementary. They add up to 180. So if I can replace that x with 9 into this expression, I can find the measure of that angle and then subtract from 180 to find the measure of angle JIH. So let's go ahead and do that. So 16 times 9 minus 20, that equals 144 minus 20, which is 124 degrees. That's this angle right here. Together, these two angles add up to 180. So I'm going to subtract the 124 from 180, and that'll tell me the measure of my angle JIH. (180 minus 124) is 56 degrees. Let's try another one. These angles intersect at M. Again, we do not know that they're perpendicular, so we can't assume we have any right angles. We want to find the value of x. From the picture, I've got expressions for two angles, and it looks like that they are adjacent because they form that line LMN. That means they are a linear pair, which means they add up to 180. So remember, linear pair means they're supplementary, which we'll talk about in a minute, but they add to 180 degrees. So that's how we're going to set up our equation. So we'll say 7x plus 20 plus the other angle of 5x plus 10 equals 180 degrees. So let's solve this equation. We'll combine our like terms. 7x plus 5x is 12x. 20 plus 10 is 30. That equals 180. Now I'll move my constants to the right. I'm going to subtract 30 from both sides. So 12x equals 150. And then I'll divide both sides by 12, my coefficient. So x equals 12.5 or 12.5. So there's my value of x. I need to go back and find the measures of both of those angles that I just added up to 180. So let's go ahead and do that. So the measure of angle LMO equals 7x plus 20. We're going to replace x with 12.5. So 7 times 12.5 plus 20 equals 87.5 plus 20 is 107.5 degrees. That's the measure of angle LMO. Now to find the measure of angle OMN, I could just subtract that amount from 180, but just to make sure, I'm going to go ahead and evaluate that expression. Angle OMN, it equals 5x plus 10. Let's replace the x with 12.5. 12.5 times 5 equals 62.5 plus 10 is 72.5 degrees. And I could verify that these two truly do add up to 180 degrees. So yes, we've done that correctly. So in that last example, we had the linear pair, which remember added up to 180. And I keep calling those kind of angles supplementary angles. So supplementary angles are two angles that add up to 180. Supplementary angles do not have to be adjacent though, like a linear pair does. So there's a distinction between linear pair and supplementary. Linear pairs are adjacent and add to 180. Supplementary angles are just two angles that add up to 180. So I could have, you know, an angle here, and then I could have an angle there. And if I put them together, they would make a linear pair and add up to 180. So maybe this one is like 120 degrees. This is horrible. And then this is 60 degrees. Okay? Now, there's also a word or a term for two angles that add up to 90 degrees. And that's complementary angles. These, again, they don't have to be adjacent. They don't have to be right next to each other. So I could have one angle here, and then maybe one angle here. Maybe this angle is 30 degrees and this angle is 60 degrees, but together, because they add up to 90 degrees, we say they're complementary. Now there's a way to remember the difference between these two. If you make an S for supplementary and a C for complementary, I can go back and with the S, I could turn that into an 8, and that'll help me remember that they add up to 180. With the C, I can draw a line and turn that into a 9, and that'll help me remember that complementary add up to 90. So those are just some ways to remember, because sometimes students do get those confused. Another term that we'll encounter is the word complement and supplement. A complement is what you add to another angle to equal 90. A supplement is what you add to another angle to equal 180. Together, the two angles are either complementary or supplementary, but one by itself is just complement or a supplement. So let's go ahead and try one more example for right now. It says if angles 1 and 2 are complements, which means yes, they add to 90 degrees, right? With angle 1 measuring 2x plus 20, and the measure of angle 2 is 3x plus 15, find the value of x. So they will add the sum, they will add to 90. So we're going to say 2x plus 20 plus 3x plus 15 equals 90. The two angles together are going to add up to 90. So we're going to go ahead and solve this for x. Let's combine our like terms. 2x plus 3x is 5x. 20 plus 15 is 35, and those add to 90. Let's move our constants to the right by subtracting 35 from both sides. 5x equals 90 minus 35, which is 55. And then we'll divide both sides by 5, that coefficient. So x equals 11. I could go back if I wanted to and plug it in, plug in 11 for x in either expression if I wanted to get the actual values of both of those measures of both of those angles. So now let's take a look at this picture and kind of put everything together to see if we can't find some of these missing angle measures. Let's start with that 45 degrees. I think vertical pairs are the easiest to identify. So the angle right across from 45 would be angle 3, and I know that those would be called vertical angles, which means they are congruent. which means angle 3 also is going to equal 45 degrees. Okay, the other angle we know is the 110 degrees, and it's across or vertical to this angle 2, which means that angle also equals 110 degrees. So that's angle 2. Let's see, angles 1 and 4 are vertical. I don't know what either of them are, but I know that because they're vertical, they're going to be equal. So I just need to find out what one of them is. If I was to cover up half my picture, so bear with me here. Let's say I cover up half this picture. Okay? And I look at this angle, and this angle together. I know that those are going to add up to 180 because together they form this straight line. Well, I know two of their measures. If I add the 110 and the 45 together, I'm going to get 155. And then if I subtract that 155 from 180, that should give me the remainder. That should be the measure of angle 4, which will also be the measure of angle 1. And when I subtract that, I get 25 degrees. So angles 4 and 1 are both 25 degrees. There you go. All right, and here's our last example. There's a symbol that you are not familiar with probably. It's this upside down capital T, and it means perpendicular. So whenever you see that, I want you to think 90 degrees, right? Perpendicular lines make 90 degrees. So ray CD and line AB make a right angle. So there's a right angle, and there's a right angle. Angles 1 and 2 together are right angles. I have an expression for angle 1, which is 6x minus 3. And I have an expression for angle 2, which is 7x minus 11. My pen is not working very well. Together, those two angles should add up to 90. So we'll go ahead and we'll set up this equation. 7x minus 11 plus 6x minus 3 equals 90. Let's go ahead and combine like terms. 7x plus 6x is 13x. A negative 11 and a negative 3 combine to make a negative 14, and that equals 90. Let's move our constants to the right by adding 14 to both sides. So I get 13x equals 90 plus 4, which is 104. And then we'll divide both sides by 13, which equals 8. So there's the value of x. Again, I could go back and I could plug it in into either of my expressions to find the actual angle measures of angles 1 and 2. All right, bring any questions you have to class.